This is a video on how turbochargers work. Turbochargers are used on high performance vehicles, large diesels, and they're used to give boost, extra power, and even fuel efficiency to the engine. On this picture, you can see this is the intake side. That's what we're going to be talking about right now. How it works is that it's connected to the exhaust turbine on the other side. It comes through here, has bearings that oil goes through, and spins very fast, about 150 RPM when it's, or 150,000 RPM when it's working. And it takes in air here, and it spins it around, comes out here at high pressure for an engine at least, into the intake manifold. And this here is connected to the air filter, and so it takes the air in at 14 psi and probably puts it out about 25 psi higher, 15 to 30 psi higher. After the air is taken out of the intake side, which is the black part here, because when air is compressed, it gives off heat. So then it's often run through an intercooler, which is like a radiator for air, and then into the intake manifold. Or it can be just run directly into the intake manifold from there. The side in front here is the exhaust side of the turbine, where in these holes, the exhaust from the engine, coming out at probably 40 to 50 psi, comes around here and comes out those blades. This is connected to the exhaust manifold of the engine, and this is connected to the rest of the exhaust pipe and the muffler. What I have here is the exhaust turbine of a turbocharger from a semi-truck on a big V8 diesel. And this is connected to the compressor. It's broken off, but it was connected to the compressor. And this, the air comes around, gets it spinning with these little tabs to a high rate, but then the extreme speed comes from the air getting pushed out of the little gaps in between. All these little gaps. So it's spinning like this. And on the back, these little grind marks. Because it's spinning so fast, it has to be balanced perfectly, or else it'll blow up and cause all kinds of damage. This here is a complete turbocharger. This is connected to the exhaust, comes up here, comes out the exhaust turbine, like this one, which is connected by the shaft through some bearings to the compressor impeller, which takes in air from the air filter and puts it out this hole at high pressure into the intake manifold. As you can see, this turbo has what's called a wastegate, and it's so that when the turbocharger is spooling, which means spinning, if it generates too much pressure for the engine, and the computer in your engine is designed to let out the wastegate at a certain pressure, open it to release some pressure so it doesn't harm your engine. This is what that is, and it pulls open a little valve that either vents excess pressure to the outside environment, or it can vent it back into the impeller and just reuse the air and again if it's generating too much boost. Okay, so this is a turbocharger installed on an engine, And so these are the exhaust manifolds, which comes off after the fuel has been burned inside the cylinder. The exhaust comes out these and into the bottom of this turbo. So let me zoom in. Which you can see it there. And the exhaust comes out this side. Comes out here to the exhaust pipe. And then so that's spinning that turbine, which comes to here, which is the compressor impeller. This silver thing here. This black pipe here that goes into the middle of it comes from the air filter, which is out of the picture. It's spooled up in there to higher pressure, comes out this pipe, goes down that pipe all the way to the intake manifold, or an intercooler, and then to the intake manifold of the engine. So that's basically how a turbo works. It's pretty simple. What's here is the intercooler, and what it is this comes from the turbo, or this, and it comes through this radiator. So when you're driving, cold air is going to pass through the radiator, and your hot air that's been compressed is going through those lines in the radiator. So then the cold air will cool it down and come out here, because air is denser when it's colder, so you can have more air go into your engine and intake manifold if it's intercooled. So this is why they need to be intercooled turbos. This volume 1 and temperature 1, that's what these stand for, volume, temperature. If the temperature 1 is 20 degrees, then the volume is let's just say V. If the temperature after being in the turbo is tripled, then the volume is tripled, but it's the same amount of air. So if you want to bring the temperature down, then you'll have more volume and still at high pressure, more volume at high pressure going into your engine. Every engine has compression, which allows the fuel to be ignited more explosively, and the turbo, it gives it extra compression before, so it's a lot. And diesels, they use compression ignition, so they ignite just because of the temperature of compressed diesel and air. But gas, they have probably a compression pressure of 500 psi, while gasoline engines probably only have 140 psi. So it's harder to turbo a gasoline engine because with lower octane fuels, because of gasoline, if you give it too much boost and pressure before it's compressed in the piston, then it'll ignite before it's ready and damage your engine.